Firefighters are still battling hotspots after a massive fire raged through a Hong Kong high-rise complex. At least 44 people have died, including a firefighter, while dozens more remain in hospital and more than 200 still unaccounted for. Authorities say the blaze spread rapidly from building to building. Police have arrested 3 men over alleged negligence. Nearly 1,000 people displaced by the disaster are seeking refuge at temporary shelters. Let's speak to Dr. Anwar Arabi, lecturer in fire safety engineering at the University of Queensland. He has several years of teaching and academic experience in Hong Kong. Dr. Arabi, thank you for making the time to speak with us. The cause of this blaze still uncertain, but looking at the scale and speed at which the fire spread through the estate, what will authorities be looking at?
So, thank you, first of all, for having me. So, yes, indeed, we don't know the source of ignition, but as you have mentioned, it might not matter so much what started the fire, but what's really important here is why did it spread so fast? In high-rise buildings, what we try to do is we try to ensure that if there is a fire, it remains contained within a compartment so that the fire can stay within this compartment for the entire duration until it gets extinguished, either due to burnout or due to firefighter intervention. What happened here, after talking to many of my colleagues in the field as well, is because of this scaffolding on the outside that completely negated the effect of compartmentation. So the fire had a way to travel from one floor to the other uninterrupted. Inside the building, normally when it's not under renovation, we even seal even the ducts that allow wires to go through because we want to prevent any fire. But when you have a flammable scaffolding on the outside, that completely makes the entire point moot.
This scaffolding, this is Hong Kong's signature bamboo scaffolding and netting. So could this have been a key reason why the fire spread to so many apartment blocks in the complex so quickly when, they use fire retardant on the netting, or they do take measures in this case to prevent fires from spreading? So what would have happened in this situation?
This is such a fantastic point. Thank you for bringing it up. So nothing is really fireproof. If something has carbon in it, even with fire retardants, provided it has sufficient heat flux applied to it, then it will burn. It doesn't have to start with the bamboo. It can be any small localized fire, and if that supplies sufficient heat for a sufficient duration to the scaffolding, that will, or to the material that's applied, that may overcome the effect of fire retardants. And in the end, bamboo is a natural material. It's a wood. It's a timber. So it's basically made out of sugars and polymers, all of which are combustible. So when you subject that bamboo to a high enough heat flux, again for a sufficient duration, it will ignite. So the fact that it hasn't happened to this scale before, or we've seen them actually happening more often recently, is just that this time it just happened to be at a scale that is many are comparing to Grenfell. When you look at the pictures, how it spread to between buildings, it's even worse. Some of my colleagues have called it a wildland urban fire. So it's the same as a forest fire, how the fire spreads between trees.
So does this then come down to fire safety of the renovation works? Were there appropriate measures in place for these buildings that were under renovation?
As I understand, bamboo scaffolding is being phased out. Last I checked with my colleagues in Hong Kong, and it is due to this the concerns about its fire safety as one of the reasons for that. So when you have the renovations taking place like this, the building is at its most vulnerable, really, because it is a flammable scaffolding. And I'm not sure anywhere else in the world uses a flammable scaffolding like Hong Kong does, at least not at the scale that Hong Kong does. Having lived in Hong Kong, we need to build at a scale to accommodate the population that no other place in the world needs to build at almost. So we get these buildings very, very close proximity to each other. We need to accommodate all the people, so we keep trying to build higher and closer to each other to make use of the limited land resources that we have. If you know about in Hong Kong, housing is such a big issue. When children are born, as soon as they are 18 years old, they have to register if they want to get a foot into the public housing that's available, given that Hong Kong has the world's most expensive real estate. And so what happens is you have families living in very small spaces with lots and lots of fuel accumulating because of so many people living in small space, that every apartment actually becomes it's so full of fuel that it is able to burn and generate heat that continues to propagate the fire. And as we've seen, for example, in the Grenfell fire, when the fire is outside and spreading vertically, that's how fire likes to spread because of buoyancy. So the fire will tilt and will touch the solid, causing the solid to degrade and release combustible gases that will allow it to spread. So the fact that we see it spreading vertically in such a fast pace is, to me, to be honest, not very surprising, although the fact that it happened is really unfortunate.
You made the key point about the fire spreading vertically. It spread so quickly, and firefighters had said they had a really difficult time getting to the top floors of those buildings. When it comes to fire safety, when it comes to situations like this, when a fire is spreading so quickly, what needs to be done to help get people out as quickly as possible? Or what systems need to be in place to prevent it from happening, that people get trapped? There's reports that more than 200 are still unaccounted for and maybe trapped in the upper floors of those buildings.
Indeed, and this is another really important point. Thank you for bringing it up. So when we design buildings for fire safety, we work in what's called the fire safety strategy. So the goal is to bring in all the components that we can work with to ensure we achieve the objectives of everyone getting out safe. And sometimes we have secondary objectives like protection of property. So usually in high-rise buildings, what we do is we do a staged evacuation. So when there is a fire on a specific floor, you evacuate that floor, and sometimes one or two or three floors above and below it at the same time, so that you ensure that the people are able to use the stairs without having congestion, without having crush, because you don't also want to keep the fire doors at the stairs open for too long, because you don't want smoke to come in, and you don't want the pressurization inside the stairs to go. If you open too many doors, then you're basically poking holes in a balloon in many stages. You lose pressure, so you don't want to do that either. So all of this is under the assumption that the fire is not going to spread vertically. So we try our best to make sure to limit that vertical spread as much as practically possible. That's why here in Australia, for example, and again, after the Grenfell fire, there is such a push to look at building facades and ensure that these building facades are, to as much as practical, non-combustible. And if they are combustible, that fire would not spread at a rate that would compromise occupant safety. But again, that's for the building. Once you put something on the outside of the building, you wrap the building with, some of my friends or some of my colleagues have called it an external facade or an added facade that doesn't matter what you do, because you haven't designed for a scenario like this, which completely throws off your strategy to begin with.
I want to go back to an earlier point you made about how densely populated Hong Kong is. And so because land resources are limited, a lot of buildings are built very high. These These buildings in this complex were about 31 stories high. So in terms of very tall building structures, what measures need to be put in place to ensure fire safety, especially for those living at the top?
Very, very good point. So there is the building design needs to be needs to account for all the occupants escaping, and we already do that. So we do calculations on how many people are going to be in the building, how long it takes them after they hear the fire alarm to actually spring into action, and then how long it takes them to get from their apartment to the stairs, and then how long it takes them to go down. So that's one thing. The next thing is to ensure that there is not going to be either horizontal or lateral flame spread. So you don't want the fire to spread horizontally on the floor. So you make sure, for example, the doors are fire rated so that if there is a fire in an apartment, it will stay within the apartment. The building occupants will, or the apartment occupants will escape, the door will close, and then the fire will just stay within that. So you make sure that the door can sustain a fire for a specific duration. Same for the walls and the and the windows and the facade. Now, if the fire were to spread, then by that time that it manages to breach that compartmentation, people would have already escaped. So people on the fire floor and the floor below will have already escaped. They'll be fine. At least that's the idea in principle. Now, for vertical spread, which is perhaps the worst case, you ensure that there is no combustible facade on the outside of the building or no continuous facade, combustible facade. So if there is a fire that's coming out of the windows or anything, it doesn't burn the facade. It doesn't cause the facade to ignite and then proceed to spread fire vertically. What if the fire was inside the apartment? Well, you don't want any penetration between your floor and above floor. So if there's cables or if there is plumbing, and even horizontally, not necessarily only vertically, you seal those penetrations so that the fire is not able to escape. And all of this it relies on using, of course, I would venture to say, certified materials and components and systems that have been tested under specific conditions to meet some specific recommendations for, or some specific requirements for fire safety. So the door, for example, after a set period of time, if you touch it on the outside, even if there is a fire, you shouldn't feel any heat. Same for structural members. The structural members, particularly in tall buildings, need to be designed such that the fire won't affect their structural stability, which can be a huge problem, as we had seen in the World Trade Center collapse disasters as well, or terrorist events. And so that's also a very, very important thing to do. And in Hong Kong, they have a very strict regulatory environment that tries to ensure that all of these things are adhered to. Now, the problem is that's under the assumption that this is your building. You design your building for a specific scenario. If you do something on the outside, or if you change that design, that also needs to be approved. I am not personally familiar with what the regulation is about maintenance or the works that require scaffolding or what kind of approvals would be needed. So I'm not sure about those in particular. But when it comes to the building, we try to make sure that the building, under any reasonable fire scenario or any fire scenario that could take place, that the building will stay standing, the people will escape, they would be, or rather, they would be afforded the best chance to escape and make it out safely.
Thank you, Dr. Arabi, for sharing your insights with us. We were speaking to Dr. Anwar Arabi. He's lecturer in fire safety engineering at the University of Queensland.